Right now, somewhere online, a headline is screaming that Hubble just broke the internet, as if it happened 5 minutes ago, as if scientists are still refreshing their screens in disbelief. People are sharing it, arguing about it, reacting like it's breaking news. Here's the truth nobody wants to slow down and tell you. Hubble has been floating up there, quietly working for over 3 decades. It didn't just wake up and shock the world 5 minutes ago. What actually happened is bigger than a headline, and far stranger than most people realize. Because Hubble didn't almost fail once. It almost failed from the very first day it opened its eye. And the story of how humanity fixed a billion-dollar mistake floating 340 miles above Earth, using nothing but astronauts, hand tools, and sheer stubbornness, is the real reason Hubble is still breaking the internet more than 30 years later. This is the real story behind the telescope that was born, broken, nearly canceled, nearly abandoned, and somehow became the most productive scientific instrument humanity has ever built. Rewind to April 24th, 1990. Space Shuttle Discovery lifts off carrying a school bus-sized telescope named after astronomer Edwin Hubble, the man who first proved the universe was expanding. NASA had been dreaming about this exact mission since the 1940s, decades before the technology to build it even existed. Scientists promised Hubble would see further and clearer than any telescope in human history, unclouded by Earth's atmosphere for the first time ever. Expectations were enormous. Funding had been enormous. Everyone was watching. Then Hubble opened its eye, and the images came back blurry. Not slightly blurry, catastrophically blurry. NASA had spent over $1.5 billion building the most advanced telescope ever launched, and it couldn't focus. Engineers on the ground scrambled, running test after test, until they finally found the problem. And it was almost too embarrassing to say out loud. Hubble's primary mirror had been ground to the wrong shape, off by a fraction of the width of a human hair. A mistake smaller than a grain of sand had turned a billion-dollar telescope into a very expensive, very public failure. Late-night comedians mocked it. Congress questioned it. Newspapers called it a disaster. And for 3 years, Hubble sat in orbit, technically alive, practically useless, a symbol of everything that could go wrong with big science. So NASA made the call. Rather than write Hubble off, they decided to fix it, in space, with astronauts. Something nobody had ever attempted at that scale before. In December 1993, 7 astronauts launched aboard Space Shuttle Endeavour on what became one of the most difficult repair missions ever flown. Over 5 consecutive spacewalks, stretched across more than 35 hours outside the shuttle, astronauts installed. A device essentially built to give Hubble glasses. A corrective optics package designed to counteract the flawed mirror before light ever reached its cameras. No practice run existed, no do-over was possible. Fail, and Hubble stays blind forever, a multi-billion-dollar mistake permanently orbiting Earth as a monument to human error. It worked. The very next batch of images Hubble sent back didn't just look better, they looked like they'd come from an entirely different telescope. Stars that had been fuzzy smudges snapped into sharp, glittering points. Galaxies that had been shapeless blurs revealed spiral arms, dust lanes, and colors nobody expected to see so clearly, from 340 miles up. The telescope that had humiliated NASA on the world stage was suddenly the most celebrated scientific instrument on the planet, and it had barely started. Then came the moment that changed how humanity understood its own place in the universe. In December 1995, astronomers pointed Hubble at a tiny, seemingly empty patch of sky near the Big Dipper, a region so dark and blank that most telescopes would call it nothing worth looking at. For 10 straight days, Hubble stared at that one speck, gathering the faintest whispers of light for hour after hour. When the image finally came together, scientists weren't looking at empty space anymore. They were looking at roughly 3,000 galaxies packed into a patch of sky smaller than a grain of sand held at arm's length, each one containing billions of stars, some of them among the oldest and most distant objects human eyes had ever seen. That image, the Hubble Deep Field, quietly rewrote the size of the known universe overnight. Empty sky wasn't empty. It never had been. Sit with that for a second. A patch of darkness the size of a pinprick, and inside it, thousands of entire galaxies, hiding in plain sight the whole time. Hubble kept going. In 2003 and 2004, astronomers pushed even further, staring at an even smaller, even darker patch of sky for nearly 300 combined orbits around Earth, an exposure that added up to roughly 11.3 days. Hubble Ultra Deep Field captured galaxies so distant their light had been traveling toward Earth for over 13 billion years, meaning Hubble wasn't just looking far away, it was looking back in time, catching glimpses of the universe as it existed when it was less than 1 billion years old, barely a toddler compared to its current age of roughly 13.8 billion years. But here's where it gets genuinely disturbing, because the deep field images weren't really the shock. The shock was what Hubble's data did to a number scientists thought they already understood. For most of the 20th century, astronomers assumed the universe's expansion was slowing down, dragged backward by its own gravity like a ball thrown into the air, eventually falling back to Earth. In 1998, two independent teams using Hubble's observations of distant exploding stars, called supernovae, found something that shouldn't have been possible. The universe wasn't slowing down at all. It was speeding up. Something invisible, something scientists still can't directly detect or explain, was actively pushing galaxies apart faster and faster the further apart they got. They named the mystery force dark energy, and to this day, nobody actually knows what it is. What scientists do know, largely thanks to Hubble, is that dark energy makes up roughly 68% of everything in the entire universe. More than dark matter, more than every star, planet, and galaxy combined. Humanity's most familiar, most visible reality, matter itself, turns out to be the minority. That discovery alone won a Nobel Prize in 2011. And it wasn't even Hubble's biggest headache to hand astronomers, because Hubble also helped measure exactly how fast the universe is expanding. A number called the Hubble constant, named after the same astronomer the telescope itself was named for. And the number Hubble kept producing didn't match the number a completely different method, based on the universe's ancient afterglow from the Big Bang, kept producing. Two separate, extremely precise techniques, both trusted, both peer-reviewed, both refusing to agree with each other. Scientists have spent years trying to explain away the mismatch as measurement error. It won't go away. Some researchers now suspect it's pointing at something missing from physics itself, some undiscovered ingredient in how the universe actually works. Nobody has solved it yet. Hubble just keeps handing astronomers a puzzle piece that doesn't fit the picture everyone assumed was already finished. And then there's Eta Carinae, a star system that sounds almost too violent to be real. Sometime in the 1840s, decades before Hubble existed, this massive, unstable star system briefly became one of the brightest objects in the night sky, then faded, all without fully exploding. Astronomers call it a supernova imposter, a star that nearly died and somehow didn't. Hubble's images revealed the aftermath in stunning detail. Two enormous lobes of gas and dust blasted outward from the star at speeds exceeding 1.5 million miles per hour, glowing in violent colors that look less like astronomy and more like something out of a nightmare. Eta Carinae is still sitting there today, unstable, overdue, and considered one of the most likely candidates in the galaxy for a genuine supernova, possibly within the next 100,000 years, an eye blink on cosmic timescales. Hubble has been quietly documenting the countdown. Then there's the Pillars of Creation, the single most recognizable image Hubble has ever produced. Towering columns of gas and dust inside the Eagle Nebula, some stretching nearly 5 light-years tall, tall enough that comparing them to anything on Earth feels almost insulting. Inside those pillars, new slowly collapsing pockets of gas into fusion furnaces bright enough to eventually burn the pillars away entirely. Here's the part that quietly messes with people once they understand it. Astronomers now believe a shockwave from a nearby supernova may have already destroyed the Pillars of Creation thousands of years ago. If true, the towering structure in that famous photograph might not even exist anymore. Humanity may be looking at a ghost, a structure so far away that its light is still arriving long after the real thing was wiped out. Not everyone agrees the mystery ends there either. Some scientists argue Hubble's observations of the early universe exposed something even stranger. Galaxies that appear too big, too bright, and too mature to exist as early as they do. Under the physics currently used to explain how galaxies grow, these ancient giants shouldn't have had enough time to form. One explanation suggests galaxy formation happened faster and more efficiently in the early universe than current models predict. It's an unresolved argument still being fought over in academic papers, and testing it properly will likely require Hubble's newer, more powerful successor to gather even more data. So the question just sits there, unresolved. One more loose thread hanging off a telescope that's been quietly rewriting textbooks for over 30 years. There's also the sheer number of worlds Hubble helped confirm exist beyond our own solar system, a field that barely existed when Hubble first launched. In 1990, not a single planet outside our solar system had ever been confirmed. Hubble helped change that, directly imaging distant exoplanets, analyzing their atmospheres by studying starlight filtering through them, and detecting water vapor, methane, and other chemical fingerprints on worlds trillions of miles away. Thousands of exoplanets have now been confirmed across the galaxy, and Hubble's fingerprints are on a significant chunk of that entire field, a scientific discipline that essentially grew up alongside the telescope itself. And then there's the moon of Jupiter that should not be as unsettling as it turned out to be. Europa, a small icy world with a surface so smooth and cracked it looks almost artificial from a distance. Hubble spotted what appeared to be plumes of water vapor erupting from cracks near Europa's south. Pole jets potentially connecting the surface to a massive liquid ocean believed to be sealed beneath its icy shell. An ocean scientists suspect may contain more liquid water than every ocean on Earth combined. Nobody expected a small, frozen moon orbiting a gas giant to be secretly hiding one of the most promising places in the entire solar system to search for alien life. Hubble simply happened to be looking at the right moment to catch it venting. Even Hubble's own mistakes turned into unexpected discoveries. In 2006, engineers noticed one of Hubble's gyroscopes, the spinning devices that helped the telescope aim with pinpoint precision, was failing. Then another failed, then another, until Hubble was running dangerously low on the stabilizing hardware it needed to function at all. NASA had to get creative, developing entirely new operating modes that let Hubble keep pointing accurately, using fewer working gyroscopes than engineers ever designed it to rely on. A telescope built in the 1980s, using electronics that would look ancient next to a modern smartphone, kept adapting, kept surviving, kept finding new ways to function, long after its original design specifications said it should have quietly failed. That's what makes calling this just now almost misleading. Hubble launched in 1990. The shockwaves from what it's found are, in a very real sense, still spreading, still rewriting what scientists thought they understood about literally everything. There's something genuinely hard to shake about how close humanity came to losing all of it. If NASA had written Hubble off after the Mirror disaster in 1990, if Congress had pulled funding instead of approving that first repair mission, none of this happens. No deep field, no dark energy discovery, no pillars of creation, no confirmed water plumes on Europa. An entire generation of astronomical discovery, quietly erased before it ever had the chance to begin, all because of a mistake smaller than a grain of sand. Instead, astronauts flew up, floated outside a spacecraft hundreds of miles above Earth with nothing but a thin suit between them and the vacuum of space, and fixed it by hand. Then they went back, again in 1997, again in 1999, again in 2002, and one final time in 2009, each mission adding new instruments, replacing failing hardware, physically extending the life of a machine nobody was supposed to be able to repair once it left the ground. 5 separate servicing missions, astronauts turning a broken telescope into arguably the single most productive scientific instrument human beings have ever built. And unlike a machine that simply keeps running because nobody's gotten around to shutting it off, Hubble's survival wasn't an accident. Humanity chose it, repeatedly, at real risk to real astronauts' lives, floating hundreds of miles above the ground with no rescue plan if something went wrong. Right now, this exact moment, Hubble is still up there, still orbiting Earth roughly every 95 minutes, still pointing its flawed, then fixed mirror at galaxies billions of light years away, still quietly gathering light that started traveling toward Earth before our own planet's continents had finished drifting into their current shapes. It shares the sky now. With its newer, more powerful successor, the James Webb Space Telescope, launched in 2021, built to see even further using infrared light Hubble was never designed to detect. But Webb didn't retire Hubble. NASA still runs both simultaneously because they see different things in different wavelengths, and together they've produced discoveries neither could have made alone. So here's the real shock, once you strip away the fake urgency and let the actual story sink in. Humanity built a telescope, watched it fail publicly and humiliatingly on the world stage, then chose to fix it by hand in the vacuum of space, rather than let a billion-dollar mistake drift uselessly overhead forever. Somewhere in that tiny, seemingly empty patch of sky, near the Big Dipper, thousands of galaxies are still sitting there, exactly as they were the day Hubble first found them hiding in plain sight. Whatever else is still waiting out there in the dark energy nobody can explain, in the water vapor venting off a frozen moon, in galaxies too old and too bright to make sense. Yet, humanity decided a flawed piece of glass floating above the atmosphere was worth fixing, worth risking astronauts' lives for, worth 3 decades of quietly staring into the dark until the universe finally started answering back.